Good everyone, my name is Graphics. Today we want to study an aspect of mechanical engineering science, which is also an aspect of structural mechanics, and we do call it strength of material also, where we want to analyze this figure. Now this figure you see before you is a beam. A beam that is supported by two different supports, which is the hinge or the pin support and the roller support. And this beam is loaded, but it has two different kind of loading that it is experiencing. One of those loads is point load, which is 10 kN each, and the other of the load is the UDL, uniformly distributed load, which is spread across the beam, that is 10 kN per what? Per meter. So every 1 meter is what? 10 kN. Now we want to analyze this beam and see what the reaction is, because whenever there is a load there must surely be a reaction. So let's see how these supports are reacting to this load. Now the first thing you have to do is for you to draw your free body diagram, where you can transform this UDL into what? Into point load. Then you will now analyze. Now let's see. The free body diagram here, we'll call it FBD, right? It's a diagram that is used to show all the external forces acting on an object. Now when I should draw this, I'll be having something like this. If you look at this, since this is a hinge support has two reactions. Let's name this to be point A, and let's name where this reaction will be. We'll call it point B, or let's say here is point B, here is C, and here is what? D. Let's give this a point. So at point A, having two reactions, we'll be having a reaction acting at this point, going upward like this, because it's a reaction is reacting against the load. So we're going to call it the RAY, meaning the reaction at point A along y-axis, and also we have the RAX this way, coming this direction. So this is my RAX, meaning the reaction at point A along x-axis. Then this is a roller support, which is always having just one reaction that is going in the opposite direction of the movement. So, and this is it here, and that will be my RBY. Right? Now after we've done this, the next thing is, before we put our point load, to avoid, or let's just put our point load from here, we know we have a distance from this point. Let's take it up a little bit. We have distance from this point to this point here, right? And we know that this is here and this is here. At the distance of this is 0.2, and this is another 0.2 here. So this is what we're having, right? So this is 2 meter. This is another what? 3 meter. This is another what? 2 meter. And the force is acting at this point here. That is for 10. And at this point, that is for 10 also, right? So this is the force of 10 kilonewton, and this is another force of 10 kilonewton. Now we said for the UDL, we want to convert it to point load, so it will be easier for us to analyze. It says every 1 meter is what? 10 kilonewton. So from point A here, right, to point B is 2 meters. So it means 2 times 10, that is 20. But the difference is that the 20 will not be acting in the middle of what? Of 2. Half the distance. So write the 20 kilonewton on it. We multiply 10 times what? The distance 2. That means from here to here is 1 meter. And from here to here is also 1 meter. Right? So if I should do that, that's what we have. So I can just do this way to make our work more easier. So at this distance here, we say this is 1 meter. Right? So the distance between them is 1 meter. That is 1. Now, this is our point C. Let's not make that mistake. Point C. Then this is B. And this is what? D. So at points between C and D, we have 3 meter acting. So we say 1 meter is 10 kilonewton. So 10 times this 3 is what? 30. So 30 will be acting at the center of this 3. 30 will be acting at the center of the 3 here. So put it this way. I'll write 30 kilonewton. Right? Now, I'll just put this way. Extend this to this point. So at the center here, we have this. So it means here will be 1.5 meter. Here also will be 1.5 meter. So that is for that. Now the next one, the same thing, 10 times the distance 2 will be acting at the center. So that will also be what? 20 kilonewton. So I'm going to come here and put it at the center of it. So this will be 20 kilonewton acting at the center of this 2. So at the center here, this will be 1 meter and another 1 meter. So this is what we have when you convert this point load, this beam, this UDL into point load. Now the next thing we have to do, let's move up. We need to calculate for what? For the reaction. So for you to calculate the reaction, you need your condition for what? Equilibrium. So I'm going to write calculating for reaction. We use the condition for equilibrium, and there are 3 of them. The first one is telling us that the summation of all the horizontal component fx is equals to what? 0. But our condition is that we are going to consider any force acting towards the right to be positive, and any force acting towards the left is what? Is negative. So if you look at this figure here, we only have one horizontal component, which is what? Arrow AX. So that means that my arrow AX is equals to what? 0. We are done for that. Now the next one is we are going to look for this next condition, which is summation of what? EF of y. Summation of f of y, that is addition of all the vertical components, equals to what? 0. Where we are going to consider, we'll consider upward force to be what? Positive, and downward force to be what? Negative. Now, if you look at this, we have a lot of vertical force here, and they are 7 in number. We have 2 upward force and 5 downward force, right? So since the force are facing upward, they say we are positive. They are positive. So we say that arrow AY, which is positive, plus arrow BY, which is also positive, right? Then we'll start with this. Since they are facing down, they are all negative. So it will be minus 20, minus 10, minus 30, minus 10, minus 20. Each and every one of them equals to what? 0. Now, this will now mean that from here, it means that my RAY plus RBY, if you add all of them, 20 plus 10, 30, plus 30, 60, plus 30, 90. So we have minus what? 90 equals to what? 0. Now, if my negative 90 should come to this side, become positive. So I'll say that the RAY plus RBY is equals to what? 90 kilonewton. I will term it equation what? Equation 1. Now, the third condition for equilibrium is that what? Summation of moment about any point. I'm choosing point A, so I'll put some point A here, equals to what? 0. Now, I am going to consider clockwise moment to be what? Positive, and anti-clockwise moment to be what? Negative. Right? So let's see. I will use this to give you an analysis. I have my clock here that has 12, 6, 3, and 9. So we'll see what meaning to be clockwise or anti-clockwise here. We know moment is force times perpendicular distance. So since I'm taking moment about point A, it means that point A will not be used, but point A will be nothing less than what? A reference point. So if I say moment at A means force times what? Distance to point A. So this is 20. 20 Newton, 20 kilonewton is going towards this direction, towards A. So the distance of 20 from A is what? 1 meter. So it will be 20 times 1. Right? So we have 20 times what? Times 1. Plus, if you look at it's going the other way, that means it's going this direction. That's why we call it clockwise, and it's positive. The next one too is following the same procedure, and that is 10. 10 is also doing the same thing, going towards A. And distance from 10 to A is what? 1 plus 1, and that is 2 meters. So it will be 10 times 2. So we'll go there and we'll say 10 times 2. 10 times 2. Plus, the next one is this. It's 30. 30 is going towards here. Distance from 30 to point A is what? 1 plus 1 is 2 plus 1.5, that is 2.5. So we're having 2.5 there. So let's input it. So this will be 30 times 2.5. Now the next one is 10. Right? 10 is coming the same direction, and that will be 10 times, this is 1.5 plus 1.5, that is 3, 4, and 5. So that will be 5 meters. So distance from there is 10 times 5, and that will be 5 meters. We have plus what? 10 times 5. So the next one will be 20 coming this direction, right? So it will be 20 times distance from here to here, and that is 6. So 20 times 6. So let's go there and input 20 times 6, right? Then plus the next one is this RBY, that is going in this direction, going towards A. So when it goes like this direction, we say that what is negative. So negative RBY times the entire distance, which is what? 7. So minus RBY times 7 equals to what? 0. Now we'll do the summation of moments Now what we'll do is we'll start putting our value. 20 times 1 is 20, right? 20 times 1 there is what? 20, plus 2 times 10 is what? 20, plus 2.5 times 3.5 times 30 is what? We'll be having, so this is 3.5 here, times 30, and that will give us 105, plus 10 times 5 is what? 50, plus 6 times 20 is 120, then minus 7 ROBY equals to 0. Now when you add everything all together here, you'll be having 315, 315, right? Minus 7 ROBY equals to what? 0. If I take this to this side, it will have 315 is equals to 7 ROBY. Now, if you divide both sides by 7, we'll say that 315 all over what? 7 is equals to 7 ROBY all over what? 7. Right? So from here, this will equate this. We will now say that my ROBY is equals to what? 45 kilonewton. That's ROBY. Now the next thing we'll do, we need to put ROBY or substitute ROBY in equation 1. So I'm going to put it this way, that substitute ROBY equals to 45 kilonewton into equation 1. So equation 1 here is ROAY plus ROBY is equals to 90. So I'll put it there that ROAY plus ROBY is equals to what? 90. So it means that my ROAY plus 45 is equals to what? 90. ROAY is equals to 19 minus what? 45. And my ROAY will give me what? ROAY is going to give me 45 kilonewton. So both ROAY and ROBY are what? 45 kilonewton. So I'll write it here. ROAY is what? 45 kilonewton. And ROBY is equals to what? 45 kilonewton. So I have successfully calculated for my reaction. I will know ROAX here is equals to what? 0, which is just there. Now the next thing we'll do here is to calculate for shear force and draw the shear force diagram, also calculate for bending moment, and also draw the bending moment diagram. Right? Now, things you need to know before you calculate for shear force. So, calculating for shear force. We calculate for shear force at different points, right? We have only 4 points, point A, point B, point C, and point D, just like in our diagram here. Because on our main diagram, you see this is point A, point B, point C, and what? And point D. So the rest diagram is what we inputted due to converting our UDL into point load. So we don't call all these points a point. You don't assign a point that is not given in the actual question, right? In the actual question, we only have A, B, C, and D. So that's why we're sticking with A, B, C, and D. So we have shear force at these various points. So these are the points that we have. The reason why we are putting it two each point, we are measuring them twice, is because of what we are dealing with, a UDL, a uniformly distributed load in our actual question, right? I mean, it's just point load, we only take them one after the other, one each. But since it's UDL, we need to check before and after every point. So the first one is before B, after B, before D, after D, before C, after C, before A, after A. That is what we are doing, and we are coming in from the right hand side. We are moving in this direction, right? So because of that reason, I'll make you understand a fact here. Let's assume we have a beam this way, right? And we section the beam into two. That is for people coming from the right hand side. And we know this is the right hand side of the beam, and this is the left hand side of the beam, right? We know that right is positive. Let's just put the positive because right hand is positive, then the left hand is negative. Let's have Azure take that. Now if your force is facing up, right, at my right hand side, when the force is facing up, we usually say it is positive, right, in terms of statics. When the force is facing up, we say it is positive. So if you notice now, the force facing up positive, and the domain it finds itself is a positive domain also, right? So you say that the shear force is negative. That is how you remember. So we say that the shear force is negative. Similarly, if I have still that same beam this way, and I section it too, you know this is the right hand side, and this is the left hand side. Like I said earlier, the right hand domain is positive, the left hand domain is negative. So if the force is facing down, you know when the force is facing down is negative, right? Now since the force is negative and the domain the force finds itself is positive, and they are different, so you say the shear force is positive. Now let's stick with that. So since we are coming from the right hand side, let's stick with that. So now let's start. Now I'm coming from here. If I section this part here before B, if I section before B like this, right, now we have right hand side, right, and we have left hand side. So it means from this part straight down to this part is left hand side, from this part like this right hand side. Now is there any force at the right hand side? There is no force. That is why shear force at B before B is is 0. Now if I repeat the same thing for the other aspect, now let me just clean this just for understanding's sake. Now if I go to the other part after B, this is before B, and this is after B. So if I section here this way, just after B, right? So we now have from this line I section towards the right, we'll call it the right hand side. Then from here to this side, we'll call it the left hand side. Left hand side, right? Now what do you notice? From here to here is left hand side, but we're coming from the direction, so I'm sticking with the right hand side. Now the force is facing up. This is the section, and the force is facing up at my right hand side. And I say when the force is facing up at the right hand side, the shear force is The shear force is negative. So it means that shear force at point B, that's after B, will give you minus minus 45. To have minus minus 45 kilonewton. Right? So we are done with that. So let's check shear force at D, but this is before before D. So I'm going to section this part here. Now if I section before D, I section this part here. Now it means that from here to this side is my right hand side, and from here to this side is my left hand side. Now how many force do I have in my right hand side? 2 force. So what I will do, I'll write my final answer that I got for B. I'll write it here, meaning minus minus 45. Right? Now what's the new force? Is 20. Now what is happening? The 20 is facing down at the right hand side, right? And we see whenever the force is facing down at the right hand side, shear force is positive, which I explained earlier. Shear force is positive. So I'm going to say plus plus 20, because the force facing down is 20. So and this is going to give us 25 kilonewton, that is minus 25 kilonewton. Is that okay? Now after doing that, I'll go and repeat this force again. I'll write it down at D again. This will be minus what? 25. Right? Now we'll go into section another part. So we'll section, we did before D, now we're going to do after D. Now after D will be just here. And I'm going to section this point here. So after D now, right? So we're having a new right hand side and we have this left hand side. So from this point downward here is right hand side, from here downward here is left hand side, right? So at the right hand side here, after I've written my final answer, the new force that's being introduced now is the 10 kilonewton that is being introduced, right? So and it's facing down at the right hand side. Now so whenever it's facing down at the right hand side, the shear force is what? Positive, just like I explained earlier. So it will be plus 10. So I'm going to add 10 to it, right? And this is going to give us minus 15 kilonewton, right? So now the final answer here, I'm going to what? Repeat it and write it down here again to give me minus 15, right? So I'm going to section a new point again. That is, I've done after D. Now the next one will not be what? Before C. So let me do that. So I'll do before C. Now doing before C now, this will now be the right hand side and this will be what? The left hand side. Now the new force I've introduced is 30, right? And from here to the right hand side, and the 30 is facing down at my right hand side. And whenever the force is facing down the right hand side, we see the shear force is what? Positive. So I'm going to add plus what? Plus 30, because 30 is the new introduced force in it. So this will now give us what? 15 kilonewton. Right? Now we'll now do after C. We've done before C, I will do after C now. So after C we'll be having this. So after C, I'm going to section it again at this point. Now this is my new right hand side and this is what? The left hand side. So from this point here, this side is my right hand side and from here to here is my left hand side. What do you notice? The right hand side is what is increasing, Abby. Now the new force introduced now is the 10 kilonewton. So what I'll do is I'll write my final answer, which is 15. I'll write it out, 15, right? And the new introduced force is 10, right? And 10 is facing down at the right hand side. When it's facing down at the right hand side is what? Positive. So I'm going to put what? Plus 10. And that's going to give us 25 kilonewton, right? Now the next thing I'll do is to do before A. The next one is what? Shear force at point A, and that point A is before A. So what I'll do is I'll go to section before A and I'll be having this. So having before A, I'll just come and section close to A this way, right? So this is my new right hand side and from here to here is what? The left hand side. So the new I'll write down my final answer, which is what? 25 kilonewton. I'll write out the 25 kilonewton here. Then the new introduced force is 20 and it's facing down at the right hand side. So when it's facing down at the right hand side is what? Shear force is positive. So we plus what? Plus 20. Plus 20 equals to what? That will give me 45 kilonewton. Right? So doing that, I'm going to put my final answer here. So this will give me 45, right? Now what I'll do is I'm going to section the other part of it here, which is after A. We've done before A, we'll do after A. So then after A, we'll be having this. So if I just section after A, so I'll have a new aspect. From this point straight down here is right hand side, right hand side, and from here is left hand side. Now what do you notice? The final answer here, the new introduced force is RAY, which is facing up. And when the force is facing up at the right hand side, the shear force is what? Negative. So you are going to put minus the force facing up, which is negative. So that will be minus what? Minus 45, right? And that will give us what? 0. So we successfully calculated our shear force here, right? So the next thing we'll calculate should be our bending moment. Now before I move to the bending moment, if you notice that I'm always cleaning all the section, it is not necessary you have to clean all the section line. I'm only cleaning them for you to have understanding of what I mean by the right hand side and the left hand side. So if you now want to come through your left hand side, now you don't want to come through this side, you want to come, no, initially look at my arrow, I'm coming through this side. Now if I choose that, okay, I want to come through this side, what will you do is that the force is facing down at my right hand side, at my left hand side. Now what do you notice? Here is negative. When it's facing, the domain is negative, and where it is, the force facing down is also negative. Once they are the same, your shear force will always be what? Negative. You still get the same answer. Now let's assume it is facing up at the left hand side. The domain is negative. The force facing up is what? Positive. Once they are different, you all have what? Positive. So if they are different, it's positive. Once they are the same, either minus minus or plus plus, the shear force will be negative. I don't know if you understand that logic. So this is how. So if I'm coming through this side, I'm going to focus on this idea on the left hand side. If I'm coming through this side, I'm going to focus on this idea on the right hand side. Now let's go to our bending moment. Now another idea coming in through bending moment is this. So I'll put it this way, that calculating for bending moment. In terms of bending moment, we have what is called hugging and sagging, right? We say if you have this way, it's more like this, and if I section it, so if the force is anti-clockwise at my right hand side, or it is clockwise at my left hand side, you see the bending moment is positive, right? So if I'm dealing with my right hand side now, once it is anti-clockwise, you see bending moment is what? Positive at my right hand side. So I'm dealing with this side now first. If I have the same thing, if it is facing down this way and it is coming clockwise, right, this is anti-clockwise here, negative. So if it's coming, I told you once they are different, to be positive. So if it is clockwise, positive at my right hand side, bending moment is also what? Positive. So we're dealing with it. So I'm coming towards my right hand side, right? Now let's see how that goes. Now here you only take just one point. So what are the points? B, D, C. Just the same thing, the way you move in terms of what? Your shear force. You move from B, D, C, A, but now this will be one after the other. So it will just be, take one B, C, B, D, C, and A. So let's do that and see. So bending moment at, so I will only take those points, but I will not repeat them, right? So we'll look for bending moment at B, at D, at C, and what? And at A. So let's see how that goes. Now if you are starting bending moment, you know moment is the force times what? Perpendicular distance, right? So if I take bending moment at B, we are coming this direction, right? Now there's no distance. So when you say the distance is 0 times the force, that's going to give us 0. So at the first point, bending moment is what? Is 0. So I'm going to put 0 there as my what? Bending moment, right? Kilonewton meter. Now I'll go to the other point again, and let's see bending moment at D. D is the next point. This is not a point, this is a point here. So this is the next point. So what do you notice? From here, from D to B, from what we calculated here, D to B, right, is giving us what? 2 meters, right? So if I do that, see what I want to do here. From D to B is 2 meters. So that means I'm moving from this point to this point, and the distance is what? 2 meters. But what do you notice? It is going anti-clockwise, negative. At where? At the right hand side. This is the right hand side. It's going anti-clockwise, and we say that whenever it is going anti-clockwise at the right hand side, what will happen? We say bending moment is what? Positive. Right? When it's going anti-clockwise, is positive. So that means this is positive. So the force is positive. So I'll put 45. 45 first. That is the force multiplied by the distance, which is 2. Because from point D to B, that's like what I illustrated here, from point B to D is 2, right? So that one point multiplying the force times the distance. So that's 45 times 2 plus, now the next force there on that domain before D is 20, and the 20 will be coming towards what? D. What do you notice? It's going clockwise at the right hand side. And I said whenever it's going clockwise at the right hand side, bending moment is what? Is negative. Are you with me now? When it's going clockwise at the right hand side, bending moment is what? Is negative. So now I'll come here, and the force that is going clockwise is 20, so we have minus 20. So we have minus 20 in bracket, we have minus 20, we're still dealing with point D, minus 20 multiplied by the distance between 20 kilonewton and 10 kilonewton is what? Let's see. Distance between 20 kilonewton and 10 kilonewton is what? Is 1 meter. So I'm going to multiply it by what? By 1. Right? Another way you can remember this is this. When the force is anywhere, you let the arrow point into the cup. This is the cup here. Right? So when the arrow is pointing into the cup, you say, what do you notice? When it's pointing to the cup, bending moment is what? Positive. And when the cup is facing up, bending moment is what? Positive. And when the cup is facing down, that means in anything you are doing, the arrow should point into the cup. Any of them you want to remember. So when it's like this, bending moment is negative. Right? Just like what we did here. Just like what we did here. Bending moment will be negative. When the cup is facing up, bending moment will be what? Positive. In any of those two you can remember. So if I want to simplify this, 45 times 2 is going to give us what? 90. 20 times 1 will give us what? 20. That will be minus 20. So we'll be having this to give us 70 kilonewton meter. That is what we have. Bending moment at point D. Is that taken? So we'll go to point C. So in going to point C, let's see. So we're now dealing with what? Point C. So this is point C here. So let's start. If I move from here, it's coming towards point C. So between, and this is going what? This is going clockwise, meaning the cup is pointing to the cup and the cup is upside down, right? So when it's going clockwise like this, bending moment is what? Negative. So we say minus 30 times distance between 30 and 10. So let's see. Distance between 30 and 10, which is this, is what? Is 1.5. So minus 30 times 1.5. I'm going to put it this way by saying minus 30 times 1.5. Minus 30 times 1.5. Right? Plus the next one is 10 kilonewton. Now if you look at this 10 kilonewton here, it's coming this direction. So you do all the force before C. You look for the moment of all the force before C. So doing of what? 10 kilonewton here, right? The distance between 10 and 10 is what? Let's check. The distance between the first 10 and the other first 10 is this. The first 10 and the other first 10 is 1.5 plus 1.5, and that is what? 3. So it will be minus 10 times 3. So we'll go to the next one, which is minus 10 times 3. Minus 10 times what? Times 3. That is the distance. Plus, the next one is this. Let's see. After the 10, we have another one, which is 20. Also going towards C. So between 20 and 10, the force is 20 and it's going clockwise. So that is also negative, right? So we have minus 20. Let's try that first. Plus, this is minus 20 multiplied by, now the distance between 20 and the 10, between first 20 and point C. Come between first 20, which is this, right, and point C, which is this. So 1.5, that is 3, plus 1, that is 4. So it is 4 meters. So distance from there to there is 4 meters, right? Then plus, let's just put it there, plus. Now we have another one again, which is point, the first RBY. The distance between from here to here, if you notice it is going this way, and that is positive, right? So if it's coming this way, it's positive. Now distance, the force is 45 kilonewton times distance from B to C. The distance from B to C, is 1.5, that is 3, plus 2, that is what? 5 meters. So 45 times 5. So I'm going to multiply 45 times 5 here at this point. We have 45 times 5, right? So at the long run, we're going to be having 30 times 1.5 will be 30 times 1.5, that will give me 45. So we have minus 45 here, minus 30, because minus 10 times 3 is minus 30. Then we have minus 80, then plus 45 times 5, that will give me 200 and what? 225. So doing you simplify this will give me minus 45 minus 30 minus 80 will give us this, then plus 225, that will give us 70. So the force of this is 70 kilonewton meter. So don't forget this. This is this one, and this is 70 kilonewton meter. That will have the right. Now the next one we'll be doing will be for point A, right? So for point A, let's see. For point A, this is point A, right? So we're going to do everything from point A to this point. So we must get 0. So let's do for point A and see how it goes. So normally, if you look from the right hand side from point A, there's no force here. So you can easily take 0, right? But just for understanding sake, let us start picking from point A and see how it goes. So I would like to do it somewhere else here. So if I'm taking for point A, let's see. From point A, I know my value is 0 because point A at the right hand side there's nothing there, so that is 0. But let's just see how it goes. From point A, this force is going clockwise, so it's negative. So we have minus 20 multiplied by distance between this force and point A is what? Is 1 kilonewton, 1 meter, right? Distance between here and point A is 1. So minus 20 times 1, right? Plus the next one is 10, going towards that direction is also negative, minus 10 times distance between C and A. Distance between C and A is what? Is 2. 1 meter plus 1 meter, that is 2. This will be times 2, plus we have this is coming also, that will give you minus 30 times distance between 30 and A will be what? That will be distance between 30 and A, right, will be 2 plus 1.5, that is 3.5, right? So times 3.5 plus, open brackets, we have 10 also, so also minus 10 because it's going this direction, minus 10 times distance between point D and A. Distance between point D, this is D and A, right? So from here, this is 1.5 plus 2, this is D and A. So from here, this is 3, 4, 5, that is 5 meters. So we have 5 plus, the next one will be what? 20. So it's still the same thing, minus 20, right? So distance between 20 to A will be, let's see, 1 plus 5, that is 6. Distance from here to here is what? Is 6. So I multiply by what? By 6. Then plus the last but not the least, which is this first coming this direction. And when it's going anti-clockwise, it is what? It is negative, right? It is negative. So we have minus, that will be, it is positive, sorry. I will have plus 45 multiplied by distance from B to A, which is 7. So we need to have, our answer must be what? 0. So let's see. So we have minus 20, 10 times 2 is another minus 20, minus 30 times 3.5, we have 30 times 3.5, and that will give us 105. So we have minus 105, minus 50, because minus 10 times 5 is minus 50. We have minus what? 6 times 2 is 12, that is 120. Then we have 7 times 45. So we have 7 times 45. That's going to give us 315. We have plus 315, right? So if I should press this, minus 20, minus 20, minus 105, minus 50, minus 120, plus 315, that's giving us 0. So shear force, bending moment at point A is equal to 0, just like I said earlier. So that is just it. So bending moment at point A is 0. So you can do this on it, or you can just know it is 0 from the left hand side. So we have successfully calculated our bending moment. Now it's for we to draw our bending moment diagram, right? So let's draw the diagram and see how it goes. Now, in drawing the shear force diagram and the bending moment diagram, I'll go back to the parent drawing, the main drawing that brought about to this, and this is it here, right? This is what I'm going to do here. This brought about this. Now I will work with this to draw my shear force diagram, right? So what I'm going to do is I'll take my rule and I'm going to project lines coming down from this point, point B, and point A, point B, point D, point B. So this is all the points that I have here, right? So I'm going to draw a line, a thick line across the span here, and this line here is 0, and here is also what? 0, right? So we'll start. So we say shear force at B is what? Let's see. The shear force at B is giving us 0. So that is the 0 point here. Now just know that the top is positive, the down is negative. So shear force at B again is minus 45, right? So at the same B is what? Minus 45, and I told you it's downward. So I can just take 45 downward, right? So I'll take minus 45 downward. So let me assume 45 is here, right? So I'm going to use this and draw a straight line down. This is 45. So I'll call that 45 kilonewton. That is the point. Now the next one is the shear force at D. Shear force at D is 25, negative 25, right? So I'll go to D. This is the point of D, the line of D here, right? So I'll go minus 25. My 25 will be somewhere around here. Let me just assume it is here, right? So it is here. So I'll just mark this point, and I'm going to put 25 kilonewton. All good. So what am I going to do? Then the shear force again, are still that same D, is what? Is minus 15, right? At the same D is what? Minus 15. So at the same D, it will be minus 15. Now let me say minus 15 is here. Can you see that? So this will be minus 15. So I'll just put the 15 there. So what I will do is I will use an inclined line to join these 2 points together. Why am I doing that? Because it is UDL. So UDL at the shear force diagram is always inclined, and I'm going to join it to this point. This 15 here. Right? Now the next one that I'm going to do is shear force at point C is what? 15, and 15 is up. So this is point C. This is C here. This point C here, right? So 15. So I'll mark 15 upward. So from here, let's assume 15 is here also. So I'll just mark that point 15 kilonewton. Right? So I'm going to still use an inclined line to join the 15 together. Right? Now the next one is still the shear force at C. Again, after 15 we have what? 25 positive. So I'm going to take 25 upward again, and that'll be somewhere around here. Right? So I'll just join this to this. That's 25. Right? So this side is 15, here is also what? 25. Now the next one is shear force at A. Shear force at A is what? 45. So that means at A here is 45. So 45 should be somewhere around here, right? So let me call this point to be point 45 kilonewton. So I will just take this rule and take it to that point 45. Then I will have, then the next one is the shear force at still the same A, also is what? 0. So this is 0 here, and I'm going to bring it down to 0.0. So this is what we have here. So I can just do this. This side is positive. Then here is negative, right? So this is our shear force diagram. Now the next thing we want to do should be the bending moment diagram. So what I will do is I'll do the same thing. I will connect this point. I'll connect this point to this point, just with a straight line, right? And we'll start. So bending moment at B, is 0, so that is a 0 here, and bending moment at D is 70, positive 70. So at D it is what? 70, and I'm going to assume this point is my 70 here, right? So this is 70, and this is what? 0. Now bending moment at what? At C again. Bending moment at C also is another what? 70, right? So I'm going to do that of 70. So at the same point is also what? 70. Then bend moment at A, according to what we calculated here, is 0 kilonewton. So here is what is 0. So what I'm drawing this, since it is inclined here, it will be like a parabola, right? And here also will be like a parabola. So when it is inclined at the shear force diagram, it will be a parabola at the other diagram. So I will just join these 2 points together with a straight line this way. So this is what we are having. So I can just do that. This is positive. Right? So this is the shear force diagram and the bending moment diagram. So if you found this video helpful, please don't forget to click on the subscribe button. Thanks for watching.